This last problem from problem set 8, so it's the modified group work game. So it's a continuous action game repeated twice. So it's like the duopoly repeated twice game. So maybe the way to solve is the same, exactly the same. So the first thing is to write down the best response function. So the best response function of firm 1 given firm 2 is just done by the first order condition. Let's not do this. So when you differentiate with respect to, let's write it as 1 and 2. So when you differentiate, you get 1 minus e2 minus 2 e1 is equal to 0. So e1 is equal to 1 over 2, 1 minus e2. So that's how I get the best response of 1 given e2 is equal to half minus half e2. So why do I not need max over them? Because e2 is between 0 and 1. This will never be less than 0 or more than 1. So we don't need the max with 0 thing. Similarly, we can get the other one. Those are the best responses. So what's the optimal thing to do? So obviously they should be equal to each other. So let's do a shortcut. I assume that they are equal, and then just e1 is equal to half 2 my e1. So move it to the other side. 2 over 3. e1 is equal to this, and e1 star is equal to 1 over 3. So basically the Nash equilibrium is 1 over 3 and 1 over 3. So that's like the Cournot duopoly. So we need the monopoly outcome as well. So the one that we want is the monopoly one. So how to figure out the monopoly one? Add them up and then find the optimal. So E1 E minus E2 plus E2 1 minus E1 minus E1 squared minus E2 squared, and then differentiating with respect to E1 gives me this minus E2 minus 2E1 is equal to 0. So here is E1 is just 1 minus E2, or half minus E2, I think. Yes. And then similarly you can get E2 should be half minus E1. So again, they should be symmetric, but then you can substitute one into another. So we know that E1 star, let's not call it star, E1 monopoly is equal to 1 over 4. So now we get both of them. So this is the monopoly outcome, which is 1 over 4 and 1 over 4. And then the next step is there needs to be an optimal deviation in the first round. So what we want, yes, I should always write this again. So Nash equilibrium of the two-stage game is always first what we want. This is the thing we want. And after what we want, no. And I would always have the Nash equilibrium after what we want. And Nash equilibrium is only this after history. 1 over 4, 1 over 4. And then we need to have a punishment strategy after history. After all other history. So how am I going to punish the other guy? So if I make it 1, then it's probably okay. Let's see why this works. So we want to minimize the maximum of the other guy. So the maximum of the other guy should be 0. If I choose anything that's less than 1, then this will be positive. Then the other guy will have incentive to choose something positive. So I don't want that. So that's why intuitively I want to make this 1. So E minus I being 1 is the punishment strategy. Because in this way the other guy can get 0. So know that, so the formally to know this, the maximum of the other guy can get sometimes is 0 only when this is 0, because then when this is 0, then the other guy only has minus something squared, so that's the maximum of the other guy being 0. So this, it's actually the smallest possible thing. So going back, so 1, 1 would be a pair of punishment strategy. So now we have the Nash equilibrium. The next thing is to check, and we did this many times already, so follow the plan and then cheat. If I follow the plan, what I will get is, okay, the number is getting messy. So 1 over 4, 1 over 4, substituting to this, so let's just write it down. So 1 over 4, 1 minus 1 over 4 minus 1 over 4 squared. Basically substitute this pair into my utility function. What is that? So this is 16 over 3 minus 1, just 2, so it's 1 over 8. So this is 1 over 8. Plus in the second round, I'll get 1 over 3, 1 over 3. So okay, a lot of work again. Minus 1 over 3 squared, so it's 9 over 2 minus 9 over 1, so it's 9 over 1. So this is plus 9 over 1. So this is my payoff. If I cheat, how am I going to cheat? So in the first round, I'll use my best response. So I'll use this, which is, given the other guy is choosing 1 over 4, what's my best response? It's 1 over 2 minus 1 over 8, which is 8 over 3. That's how I get 8 over 3. So I will cheat by doing 3 over 8 in the first round, and in the second round, how I'm going to cheat. If the other guy chooses 1, what's my best response? If the other guy chooses 1, I should choose 0, right? So I will still put it here, 1, and this is 0, so my best response is 0. So let's have it. So that's my best responding to other guy doing something that's stupid. Well, doing stupid thing because the other guy is trying to punish me. So in any case, that's my best responses. That's my optimal cheating plan. So if I do this, then I know that the other guy, so I will do 3 over 8. The other guy will still getting cheated, and then I'll do this. Okay, this is becoming impossible to compute. And then in the second round, I'll just get 0 because it's 0 times 1 minus 1 minus 0 squared. So the second round, I'll get 0. In the first round, what do I get? This is becoming very hard. So 32, maybe not, maybe 64 over 3 times 3, 9, 18 minus 64, and this is 9. So 9 over 64. So comparing this and this, which one is larger? I don't actually know. I think this one is larger, so that's why we will be following the plan. So maybe bring a calculator to calculate stuff like this.